Hello students, in this video I will continue to speak about equivalent values. In this case, I will be solving problems related to equivalent equal replacement payments. This will be the first exercise. And as always, I'm going to explain how to solve a problem like this using a problem, an actual problem. And the problems we're going to solve is this. Scheduled payments of 800 due 2 years ago and 1000 due in 5 years are to be replaced by two equal payments. So these two equal payments are going to replace these two payments. So they need to be equivalent to these two payments. The first replacement payment is due in 4 years and the second payment is due in 8 years. Determine the size of the two replacement payments if interest is 12% compounded semi-annually and the focal date is 8 years from now. For solving a problem like this, you will need to take into account, of course, the interest. And this problem says that the interest is 12%. This is the nominal rate of interest. It will be a good idea to take note of this. So we have a nominal rate of interest of 12%. Also check how this compounds. And I noted that in this case, it compounded semi-annually. So it compounds twice per year. I'm going to type then, take note of this, that n equal 2. Also, for solving a problem like this, you will always need to solve an equation. And the equation that solves this problem is this equation. This is the equation. But how I get this equation? How I know that this x is multiplying this factor? How I know that this 800 is multiplying this factor? How I know that this 1000, if you notice, these are the two payments, but these are multiplied by these factors. And we notice that in these factors, obviously appears the nominal rate of interest divided by 2, the number of compound periods, because here will appears always in these factors will appears the periodic rate of interest. And the periodic rate of interest is the nominal rate of interest divided by 2. But how I get these exponents that appears in the equation? And that's what I'm going to explain. How to get this equation. So for getting this exponent, for knowing that the equation is going to be of this way, you will need to think in the time. So for that reason, it's a good idea to draw a timeline. And I'm going to say that this moment here, this point in the time is this moment now. Why I'm finding this moment here like in the middle of the line? Because they told me that there was a scheduled payment of $800 due 2 years ago, so in the past. So I'm going to go back in the line and draw this 800. So there will be an $800 2 years ago. So between the moment that this payment is due and now, there are 2 years. So I need to take into account this. And I also need to take into account the other payment, of course. The other payment is 1000 due in 5 years. So that will be in the future. So I'm going to count 5 years. Let's see, it will be the point like this. And then this moment, there is a scheduled payment of 1000. So this scheduled payment is 5 years from now. So this will be important because you need to know the time between the values and also to know what are the exponents in the formulas that are going to appear in the equation that you are going to write. Okay, so these are the two payments, and these two payments are going to be replaced by two equal payments. If the two payments are equal and they are unknown, I'm going to represent both with the letter X. They say that the first replacement payment is due in 4 years. So from 4 years from now, I will be making here a payment. And this payment is something that I don't know. I'm using a different color just for taking into account that this is a replacement payment. With this payment, I'm going to replace these two payments. But actually I'm going to do 2 payments. But of course, okay, but this payment is, let's see, 4 years from now. So from now, and the payment will be 4 years. Again, this is important to know the exponents in the formulas that will appear in the equation. And there is another payment, a second payment that is due in 8 years. The other payment will be here. This payment is due 8 years from now. And the question is determine these 2 payments using a focal date. What is this focal date? This focal date will be a date in which I'm going to compute the value of all the amount that appears in the problem. So I'm going to compute the value of the money. In this problem, they told me that is 8 years from now. The focal date will be this point here. But actually, whatever focal date that you choose will give you a good answer of this x. It's good to put this focal date in a date when there is an unknown quantity. For example, here, there is an unknown quantity. And it's better, even easier, if this quantity is the last quantity. If you do that, it will be easier, the problem, because all the exponents will be positive. Let's see why this is important. Because you will need to decide, you will need to compute the value of this money, that focal date. And you will need to know the time between the value and the focal date. For example, this 800. This 800, I know that I need to compute the value of that focal date. And this focal date is 2 years plus 8 years. The time between the 800 and the focal date is 10 years. How I know that? The only know to know that if I have in my mind a line like this. I need to draw, some people just think in that line. Actually, it's not mandatory to draw the line, but it's good to think in this line. Okay, now that I know that there are 10 years from this 800 to this focal date, so I need to count how many periods, because this number, it will be the number n that appears in the formula. So there are 2 periods per year. These are compounded periods. There are 10 years and 2 periods per year, so you multiply 10 times 2, it will be 20 periods. For this 800, I need to compute a future value in that focal date, and this future value will have an exponent equal 20. You need to know what is the exponent in the formula that you are going to use. Okay, so this was one amount. But what about the other amount? There is another amount here that is x. For this x, you will need to compute also the future value, because this focal date is in the future of this x. And you will need to know how long is this time. And you know from now to this point in time is 4 years. And from this x to the other x to the focal date, there need to be another 4 years. Because from now to this focal date, there are 8 years. 8 years minus these 4 years give me this time here that is 4 years. So it's good to know this, thinking or drawing, whatever you want, but you need to know what is this time, because knowing this time, you will know how many periods. There are 2 periods in a year. In 4 years will be 8 periods. 4 times 2, 8. So the n that I'm going to use for this x, it will be 8. And here there is another amount. This amount is 1,000. This amount happens 5 years from now. But I need to compute the value of this amount, that focal date, because I need to compute the value of each amount, that focal date. And I need to know how long is the time between the scheduled date of this amount and the focal date. And this is from now to this amount date is 5 years, and the time between now and the focal date is 8 years. So you will agree with me that there are 3 years here, a minus 5. So these 3 years is important, because if I know this time, I can multiply by the number of periods, and I know the total number of compound periods between this 1,000 and this focal date. And I notice that there are 6 of them. So n equals 6. Now that we have all the exponents corresponding to each of the amount, we can type the equation. You can tell me that there is here another amount of money, X. Yes, you need to know the value of this X, that focal date. But this X is happening that focal date. So the value of this amount is X. So you don't need to do anything with this. And that's the reason why we choose a focal date, the date in which one of the amounts happen. So you will need to type an equation, or you will need to write an equation in which the value of these two replacement payments, that focal date, is equal to the sum of the value of the scheduled payment, that focal date. So it will be easy to type the equation. You will need to type first, for example, I prefer to type first the replacement payment. The first payment is X, this X, I'm going to type this X, plus the other replacement payment, plus the other X, but the value that this X has this focal date. And I know that this X, I need to compute the future value because this focal date is in the future of this X. So I'm going to open bracket 1 plus 0.12 over 2, and I'm going to use the exponent n equal 8 because there are 8 periods between this date and the focal date. So the sum of these two amounts will be equal to the value of the scheduled payment, that date. And the value of this 800 is obviously a future value because you need to compute the future value of this 800. So you need to open bracket, type the same factor with a different exponent. What exponent you are going to use? The n that you found before. So you know that n equal 20, so you type here 20. And here, again, for this 1000, the n will be 6. So I'm going to type plus 1000, open bracket, the same factor with a different exponent. The exponent will be 6. And all the exponents are positive because you are computing a future value of each of them. That was the reason you choose this focal date, that day. A date that is the last date that appears for a replacement payment. Now the only that you need to do is just compute all the amounts. For example, here there is an X, so you type X. But here there is an expression to the power 8, so do that in your calculators. So it will be 1 plus 0.12 over 2, close the bracket, and to the power 8. I get 1.593848075. I'm going to multiply this by X, so because this is multiplying X. Okay, so we have here this value, and this will be easy. This is 1x plus 1.593848075x. So that will be 2.593848075x. Okay, then solve this, for example, 800, open bracket, 1 plus 0.12 over 2, close the bracket, and to the power 20. So that gives me 2,565.71. You can round this number to 2 decimal places because this is money. Don't round this factor. If you round this factor, maybe you are going to get a rounding error. So try to get the maximum decimals in these factors of x. But no in the money. So you can round it to 2 decimals. Again here, 1000, open bracket, 1 plus 0.12 over 2, close bracket, to the power 6. I get here 1418.52. So this is the equation that you have now with numbers. So at 1 plus 1.593848075, that will be 2.593848075x. And add these two numbers, so that will be 3,984.23. This is an equation that is very easy to solve. The only that you need to do is divide by this number. You cancel here, but it will appear dividing at the other side. So it will be x equal 3984.23 divided by this 2.593848075. If you make this, you get the answer of x. You will know what will be the value, the equivalent value. So it will be equal to 1536.03. And this is the value, the equivalent value. So you are completely sure. We are completely sure that the size of the equal replacement payment is 1,536.03. That's what you need to do to solve a problem like this. In this case, we have the focal date here. But if we put the focal date in another date, the answer of x will be the same, maybe with a little difference because the rounding in the last decimal. So just to check how to do if the focal date is not at the end, in whatever other part, I'm going to solve a problem in which the focal date is in another point. So the same problem with the focal date in another point. Let's solve it. So as exercise number 2, I will be solving the same problem, but now when the focal date is 4 years from now. Of course, we need to take into account the interest and how the interest compound, but despite that the solution is the same, the equation will be completely different. Why? Because we have changed the focal date, and in this case, this focal date will appear in a different time. So if we think in the time at that moment, so we know that 2 years ago there is a payment of 800 that in 5 years will be a payment of 1,000, and these two payments are scheduled and need to be replaced by two equal payments, one that happens 4 years from now and the other that is going to happen 8 years from now, the other x. So that will be the same thing. The only difference is now that the focal date will be here. So what does it mean? That you need to compute the value of each amount that date. For example, this 800, you are not going to find the value of this amount like in the previous problem here. No, you need to find the value of this 800 that focal date. That focal date. So you will need to take into account how long is the time between this $800 date and the focal date. And we know that from here to now there are 2 years, and from now to that focal date there are 4 years. So in total will be 6 years. So there are 6 years between the date of this $800 and the focal date. So there are 6 years. 6 times 2 equal 12. So n equal 12. The value of this x is x because it's during the focal date. But for getting the value of the other x that day, we'll need to know how long is the time between the focal date and the date of this x. So for doing that, so we need to take into account how long is this. We also need to take into account that for getting the value of this x to this x, we need to go back in time. So I will be using the formula of present value to find the value of this x that date. And the time here is, this is 4 years, this is 8 years. We know that between the 2 days, between the two x, there are 4 years. So 4 times 2, n equal 8. So that will be n equal 8. But when I write in the equation, because when we are computing the present value, the exponent of the n is negative, I'm going to use this x, but the exponent in the formula will be negative. With this 1,000, again, we need to go back in time. So, and we need to go back only 1 year, yeah, because there are 5 years here from now to this 1,000. We took note of this. And there are 4 years from now to the focal date. So it will be 1 year here. If this is 1 year, then n will be equal to, because there are 1 times 2 equal 2. So n equal 2. And then we have all the exponents that we need to use in the equation. Obviously, these 2 will be negative. So let's do that. Let's type first the value of the replacement payment. For this payment, the value is x. But for the other payment, I'm going to compute the present value of this. So I'm going to type plus x, open bracket, type the factor that we know, that the exponent will be, but the exponent in this case will be negative 8. So I'm going to type negative 8. And the sum of the value of these two replacement payments will be equal to the sum of the value of the two scheduled payments. See this 800, so I'm going to open bracket, and I notice that for this 800, I'm going to compute a future value, because from this 800 to the focal date, I need to go in future. Yeah, I need to go to the future. How many years? 6 years. How much is n? 12. So I'm going to type here 12. Plus the value of the 1000, that focal date. So the value of this 1000 will be 1000 multiplied by the factor, but the exponent will be 2, but negative, because you are moving back in time. So you are computing the present value of this 1000. So it will be negative 2. So now that you have this, the only that you need to do is just find each of the value. You get this is x, this is 1 plus 0.12 over 2 to the power negative 8. I get 0.6274, 12,371 x, because this factor is multiplying x. Obviously, this sum is very easy because this is 1x, this is 0.6 something x, yeah? Equal 800 multiplied by 1 plus 0.12 over 2 to the power 12. I get 1609.76. Plus the other number, 1000, open bracket, 1 plus 0.12 over 2, close the bracket, to the power negative 2. And I get 890, exactly. So add together these two numbers, add together this 1 plus this 0.62 to obtain 1.627412,371x. Adding these two numbers, I get 2,499.76. And then to get this x, the only that I need to do is divide by this number. So dividing both sides of the equation by this number, I get that x equal 2,499.76 divided by 1.627412,371. I make this division and I get 1,536.03. That is the same number that I obtained before when the focal date was different. So definitely the size of the equal replacement payment is 1,536.03. Okay, that explains how to solve a problem in which we need to find equal replacement payments. So a series of equal replacement payments. I hope you have found this useful. Thank you.